So today we have an easy geometrical question. The given data is that we have two circles that are congruent to each other. This means that their radius is equal. They are intersecting with each other and passing through the center of opposite circle that you can see very nicely over there. Then there is a straight chord that has been bisected into chords, namely as 3 and 7. The chord of length 3 is in the first circle. Let it be the first circle and let it be the second circle. Yes. So this chord exists in the first one and the chord of length 7 is in the second circle. And this point has to be noted that chord 3 and 7 is a straight line, like this way, 3 and a straight line 7. It's not like 3 and 7, not a broken line, it is a straight line. So that point we have to just utilize. Second point is that you run a chord from this point to this point and you name it as x, and that's what we have to find. So let us see its beautiful solution. So yes, the first eye-catching data was that these two circles have the same radius and they pass through the center of each other. So we can have some kind of data from there. So just zooming it over here, this is the center of the first circle and this is the center of the second circle. So from this point, if I join, let it be clear. Yes, from this point I draw a chord, or we can say just a line segment from the center to this point, and this point is also lying on the circumference of this first circle. From the center of the first circle to the circumference of the first circle, it is the radius. So let the radius of this both, as they are equal, let the radius of this both is equals to r. So from center to the circumference, it is equals to r. This is the center of the second circle. I draw a line that's from this center to the same intersection point, and that intersection point lie on the circumference of the second circle also. So from center to the circumference, again the radius. Now from this point to this point, I draw a straight line. Now this is the center of the first circle, and this point, forget it's the center of the second circle, it's also the point lying on the circumference of the first circle. So it again forms a radius. We all know is that if any line is that from the center to the circumference, it's the radius. So this also becomes the radius. So what we are having is a triangle. All of the three sides is equals to r, and means what? These three sides are equal. So a triangle, all the three sides are equal. Namely, it forms the equilateral triangles and all the angle equals to 60 degree. So let's mark over there. So before marking there, we can just generate a similar equilateral triangle below this line also. From this point to this point, again the radius, and from this point to this point, again the radius. This radius according to this radius according to this, and both of them are equals. As it was told, these two circles are congruent, and this is already equals to r. So here also r means again an equilateral triangle over here. So there are two equilateral triangles, all their angles equals to 90 degree. So just drawing it very nicely and again marking all the things, removing the x, and this radius is equals to r. Now just drawing that over here again. So from here to here, from here to here, from here to there, from there to here, and in the middle. So yes, let it be clear. Yes, now all these angles were 60 over there, 60 over here, 60 on the top, 60 over here, 60 over here, and 60 over there. So what we can just observe, let this be the center of the first circle O, and let this the center of the second circle, let it be equals to P. So at angle O, its complete angle is 120 degree, and angle P completely is also 120 degree. So let us just draw these two things. We can just have two things from here separately. So just having the perspective of the first circle, so drawing that over here. So let it be clear. Yes, let it be a perfect circle. Yes, this is the first circle. This is the chord which is running as x. Remember, just see in the diagram. At the center, it is subtending an angle that is equals to 120 degree. So just writing it nicely over there. Yes, so it is subtending an angle that's 120 degree at angle O. Yes. Now the chord from here to here, it's of length 3 according to this diagram. This chord is having a length that is equals to 3. You can just have a look in this diagram. I'm just removing all these things from here. Now just have a look what I have drawn currently over there. This circle I draw, this is the chord of length x, and this is the chord of length 3. That's what I have drawn over there. And at the center it was 120 degree, just explained before, because of the two equilateral triangles. So yes, so as at the center it is subtending 120 degrees. So just discussing a theorem, if there is a circle from the same chord at the angle, some angle is subtended as theta. From that same chord, an angle subtended at the circumference point to be noted, that angle will be half the angle subtended at center. It's no matter it's over here, over there, over here, or over here. The 2 points should be there, the same chord, and the point of intersection should be on the circumference. So similar case can be just generated over here. Just removing this old things and now moving here. So this is my common chord. Let the color be changed. Yes, blue color. From here to here, this is my common chord. At the center, it is subtending 120 degree, and from that point, if I will just join a straight line to this point, at the circumference, note that this point is at the circumference. So the condition over here is all fulfilled. This is the common chord. At the center, it is subtending some angle, and at the circumference, it will subtend the angle, half the angle at the center. So at center, it is 120 degrees. So over here, it will be half of 120, that is equals to 60 degree. So just marking it over here. So that length is nothing but it's from that point to this point, and that angle over here it is equals to 60 degree. Yes, as just explained over here. And that line was also meeting at the center, so just drawing it with a dotted line, so it's look nice and clean. So this is the thing that was at the center, and it was subtending 120 degree at the center. Yes, now just taking the case of this second circle, so just changing the color for the second one, let it be equals to green. Now second circle, this is my circle, this is my common chord, and this is the chord of length 7. So we will just utilize these three things. So this is my second circle, this is the chord of length x, this is the chord of length 7, and that chord was also subtending at the center 120 degree because of the two equilateral triangles. So here 120 degrees, so at the center again over here 120 degree. So again because of that theorem, at the center 120 degree, so at the circumference half of it. So here is my common chord, at the center 120. Yes, now from that same common chord at that point, so it will be half the angle at the center. So at center is 120, so over here it will be half, that is 60, and this is the chord of length 7, this is the chord of length x. So what I got is just removing this thing from here. Yes, now what I just got, just drawing the dotted line for this center. Yes, at the center it was 120 degree from that same common chord, and from this point to this point where the chord of length 7 is intersecting the circumference, at that point it will be again 60 degree because of the theorem. Now look at this particular triangle, triangle A, B and triangle C, and this is the chord of length x, remember. Now what we will just do is just take out the triangle A, B, C from the diagram. So removing these two circles from here. These two circles, how we get the 60 degree is very simple. There are two equilateral triangles, that's why at the center 120 degree, and because of the theorem over here 60 and over there 60. Now look at this triangle A, B and C very clearly. Let it just be a look-alike. Yes, so here's the point A, here's the point B, here's the point C, and let this point over B equals to something like M. Yes, so here is my point M. Now as I told you, it was a straight line, so B, M, C are collinear. So from A to M, a chord, or we can say a line runs, and that is having a length that is equals to x. So A to M, this is having a length that is equals to x. BM is having a length 3. MC is having a length that is equals to 7. This angle over here is 60 degree. That angle over there is 60 degree. So in a triangle, two of its angle is already equals to 60 degree. So by angle sum property, the remaining angle is 180 minus 60, that gives me 60 degree. So yes, three of its angle equals to 60 degree, so it forms an equilateral triangle. This means that all the three sides are equal. So one of its side is already equals to 3 plus 7, that is equals to 10. So all this side is equals to 10, and over here also 10. Okay, now what we have to find is the chord of length x. So here is my 60 degree. This is my base of length 3. This is my one of the side that is equals to 10, and this is the x that we have to find. So what I can just think, if I will just take according to the cosine rule in this particular triangle, if I will take the cos of 60 degree, so according to the cosine rule, we just have a look at the cosine rule. If there is a triangle A, B and C, this is my angle theta. The sides are P, Q and R. The cosine rule, according to the cosine rule, the value of cos theta is square of the adjacents added together. So P square plus Q square minus the square of the opposite. So opposite of theta is R, so minus R square upon 2 times the product of adjacent sides, that is 2 times PQ. This is the value of cos theta, means it's the cosine rule we can say. So just applying it over here. So angle is, instead of theta we have 60 degrees, so cos 60, square of the adjacents added together, so tan square plus 3 square minus the opposite square, so minus x square upon 2 times the product of adjacents, that is tan into 3. and that is equals to value of cos 60. Value of cos 60 is 1 by 2, so we can just have it directly over there. Now what we can see is a single equation, and the only variable present is x, so we can just have a nice value for x. So 2 and 2 got cancel out. Tens, let that be bold over there. Yes, so 10 square plus 3 square is 109 minus x square, and that is equals to 10 into 3, that's 30. 10 into 3 multiplied with 1 over there, so x square. So from here 30 over 1 over there, x square come over here, so 109 minus 30, and that is equals to x square. So x square is equals to 79. So from here we have that x is equals to square root of 79, and that's our answer. That value of x, that was a chord between the two intersection point, is equals to square root of 79, and only the positive root because x is a side length. What we did is that two equilateral triangles formed according to the center, so complete angles becomes 120, 120. That was the various specifications over there. Then because of the theorem, at the center 120, so at the circumference half the angle, so 60, 60, and that triangle ABC, and we have just took out the triangle from here. As I was telling from beginning that the chord of length 3 and 7 is a straight line, so it formed a straight line. So form an equilateral triangle, all the sides equals to 10, and last a normal cosine rule. We can have anything after this triangle, we can use anything, the properties of equilateral triangles, the Stewart's theorem by drawing a perpendicular Pythagoras theorem. There are many things to be done. I went with this way, but after these triangles we have 2 and 3 ways to just have the value of x. I used the cosine rule. You can have anything. The correct answer is x is equals to square root of 79. So this was my method to solve this particular question. If you have any other method other than this, you can do comment below, or else you can DM me on my Instagram. Link is in the description. When someone gives a better solution to the same question, and we can show it to our viewers, it's best knowledge.